Okay.
Right. So how was your experience with the assignments? They were a little harder, I
Yeah,
guess.
it was a bit harder for me. At least last two programs, I
Yes.
took lot of time actually.
Yeah. Yeah. Yeah.
Even
So
I felt RS was little harder.
okay. Okay. So I will make it little easier now. Few more examples where similar kind of programs will be asked. Because when I try to raise the bar, you will also attempt. So that is the thing.
Yeah, yeah. Actually, this was helpful, sir.
Okay.
So yeah,
Anyway, we'll see a mix and match of easier ones and slightly difficult ones. Because at least one of or two of them should be difficult, so that you should feel that you are challenged and you will attempt to do it well. Okay.
yeah.
Uh, okay. Okay. Good. Now, what I intend to do today is nesting of if statement and also nesting of for loops. So you might have done it somewhere, but it's good to see how we can do nesting uh, if and for loops. So there are numerous situations where you require nesting, and you should be careful while nesting the if statement by proper indentation. Now we looked at largest of three numbers, right?
Yeah.
So can I do this using nested if? And in our earlier approach, we saw we had to use extra variable called as largest. And by putting couple of if statements which are independent of each other, we could achieve the task of finding the largest. But without that, can I get largest of three without using a extra variable? So let's begin. Let's say we have a couple of values here. Let us say 7 or something. Now, first step I do is if A greater than B. All right. So in this case, A greater than B, I need to check whether A greater than C, right? Only then I can declare A as largest. So in the nesting, what I do is if A greater than C also, then you can say printf percentage D largest and here A. Okay. So what do you think? What will happen in the else part here?
Mm,
See, A greater than B, 11 greater than 9, okay, it will print like that. Uh, but if A is not greater than C, suppose C were 17, that is the case, no, now.
yeah.
A greater than B is correct. It will enter here. Here you check A greater than C.
Then
Right?
it
It is
will,
false. So in the
go
else
away.
part, I
Yeah.
simply have to print C as the largest, right?
Yeah.
Right? It is obvious because if this fails, C should be largest. All right. Now this is if else that is over now. Now there is one more if whose else is pending. So what will happen here? We know that A is less than B. It means B is greater than A. I only need to check if B is greater than C now, right? If so, printf B is largest, right? And what do you think in the else part?
C.
Yeah, C largest, right?
Yes.
Can I conclude like that? Because this is the obvious situation where you know that A is less than B. And if B is also less than C, then C must be larger than the other two. Correct? So you can just trace it and see. Suppose C were the largest. Now in the case C is the largest, right? So what will happen here? It will end here only. C largest is correct. Suppose uh, B A less than B. Let us say here it is A can be thought of as, you can change this value, let us say 5. Now in this case, what will happen? A greater than B? No. It will go to this else part, right? Okay. So
Yeah.
there you are checking B greater than C. B is less than C. So again, one more uh, largest C statement should come here. Okay. So in this scenario, B is less than C. It will go to else part, and we have to declare that C is the largest. Okay. So let us implement this and see, so that you are convinced that it works. So quickly we'll declare three variables: int a equal to 7, b equal to 9, c equal to 19, let us say. Now first if is a greater than b, then you're going to check if a greater than c. So if a is greatest among the three, then you are printing a largest. So here I would write percentage d largest, and you are going to supply the variable name a here. So in place of percentage d, a will be printed. So it will print as 7 largest if at all it is. Now it is not the case. So in the else part here, a is less than c. A is greater than b, but a is less than c. So c must be the largest. So we must declare c largest here. You can put is, or you can remove this. So we are done with this inner if else, but outer if has to be considered. Here we know that A is less than B, right, in the else part, isn't it? A less than B, because only when A is less than B, it will go to the else part of this outer if, correct?
Yes.
Yeah. Now here A is less than B, okay, but we don't know whether A is B is greater than C or not. Here again I have to check if B greater than C, printf percentage D largest is going to be B, and in the else part printf percentage D largest, and here going to be C. So you will see that largest C appears twice. Okay. So for if you put the indentation right, we'll reposition these things so that it is clear how the flow is. So if whenever you write nested ifs, try to align these things correctly so that you get a clear picture of what is happening. All right. Now if you make B19 or B29 here, see whether it works for you. Is A greater than B? 7 greater than 29?
No.
No. So where should it go? You straight away go to line number 13. It will go to the else part here, right? So there I am checking whether B is greater than C. Yes, no, no. So
Yes.
it will print B largest. All right. Suppose if it were 9 here, so what would have happened? Is A greater than B? No. Again go to else part, but again you are checking B greater than C? No. In the else part, C is the largest. So now if I run the program, I'll get C largest. That is 19 largest. Okay. So there is some printf statement which is coming here. You can remove or put it at the beginning. I can remove whatever. So this case is verified. You can put this 29 and see whether you get 29 as the largest. You see 29 largest, and now you make first one largest, 37, This turns out to be largest number. Okay. So as you can see, the logic when you build with nested if sounds little complicated. You could have done it without using too many if-else statements by using AND operator, right? I told you that you can use the AND operator to combine these two first if statements. You could have written like this: if A greater than B and A greater than C, A largest, like this. But the purpose of showing is you can do a lot of nesting and get the same answer. All right. Yeah. So you should judiciously use the appropriate nesting of if statement. Is this point clear? Shall we move on?
Yes, sir.
Okay. Now, more interesting part is about nested for loops. Okay. So the many occasions are there where you have to do a nesting of for loop. So what are the use cases where you have to do nesting? All right. So you'll see one simple example. Let us say I have to print a pattern like this. I want one star to appear on one line. Second line, I want two stars to appear. Third line, three stars. Okay. Fourth line, four stars, like that. So in general, if you have n is given, so if n is equal to 4, this is what should happen. Okay. Now, how can I generate this kind of a pattern using for loops? Right. So this is a very interesting use case where given a value of n, I can generate a right angle triangle of stars like this. So let's see how I could have done this. So first thing is in your program, you read n through keyboard. Okay. Then see, we have to, first thing, if you observe this problem, there are two things. First is you have to count the number of rows, that is row number 0, row number 1, row number 2, row number 3. Whatever n value is given, you should go from 0 to n minus 1. That is, in the for loop, I should say I equal to 0, I less than n, I plus plus. Okay, so if you observe n is 4, so the loop will go from 0, 1, 2 and 3. Okay, 4 will not be counted. The moment it becomes 4, it is equal to 4 and this loop will come out. So one for loop will count the rows. Okay, and second for loop is required because you are in each loop you have to display the stars. Okay, how many stars to display depends on the row number. If row number is 0, you have 1 star. Okay, in row number 1 you have 2 stars, like that. So 1 more than the row number. Correct? So the way to do this is for I equal to 0, I less than n, I plus plus. Then you should take one more loop here for j equal to, again 0, j less than equal to I, correct? J plus plus, and then give a printf here. Printf percentage C here, or you don't require percentage C, you just have to put 1 star, print the star only, and leave little space here so that there is a space between the stars. Now if you observe, when I equal to 0, this inner loop will go from 0 to 0. So one time it is executed, you will get 1 star. Okay. Now after you come out of the for loop, you should go to the next line. Here it is not going to the next line, it is going to print the stars in the same line. So when you come out of the for loop, here you give a printf just a slash n to go to the next line. Before you begin the next line, you go to the next line and do that. And since this printf is in the outer for loop, the flower bracket should appear here, because this statement and this statement together form the inner content of the outer loop. Okay, so when I is equal to 1, it will go from 0 to 1. There are two stars will be printed, and after that it's going to the next line. Again it will go back, it will take I equal to 2, then there will be 3 star printed, and like that. Okay, so is the logic clear here, or any doubts? Hello,
It's clear, sir.
it's clear. We'll go to the implementation.
Yes, sir.
Yeah. Okay, now first thing is you give a prompt, enter value of n. And for this you have to declare value an integer variable here. So whatever variables that you want an I and a j and n. So 3 variables are required, you declare them here, and you do a scanf here, scanf %d comma ampersand again. So you have read value of n. So now you should start a loop for I equal to 0, I less than n, I plus plus. So this will count the number of rows. Then put a flower bracket. Within this block, you should print the stars in each loop depending on in which row you are. So you should take j equal to 0, j less than or equal to I, j plus plus. So the j value will go only up to I when you are in the ith row. Okay, so that is why here the expression is j less than or equal to I, and then you say printf star and little space here. Okay, and then before you return back to the outer loop, you should do one printf with /n, so that your cursor moves to the next line before starting the next loop. All right, so now if I run the program, it will ask for the value of n. So if I enter 4, you get this. Would you all like to try this?
Yes, sir.
Yeah, so go ahead, use online GDB or whatever editor you have. So just see if you can do this. How do you get a pattern which is a inverted image? That is, if you have 4 stars on the first line, 3 stars on the second line, like this. Can you modify the code to get this?
Yeah, yes, sir.
So for n is equal to 4, this is how it should appear. See what all changes you have to make to get this. The hint is you need to modify only the inner loop. Outer loop remains the same. The number of stars should progressively become less and less, right? So where do you make the change, and how do you get it? Any guesses?
Yes.
Yeah, you can type in what modification to be done if you got it. Very little change is required. Just think of. Any of you are getting it, you can post it here. You want more stars in the first row, less in second row, further less in third row, and just one in the last row. So see where the change has to be done. G equal to, yes, one of you got it. It's good. We know it could do it. Yeah. Take a little more time, think. You can use a reducing loop. We have seen how to use reducing loop or the reverse loop. It starts with large value of index variable and then progressively becomes 0. Or you can think of any other alternative which is easier. Got it? So if I tell you what is the change, you'll be surprised, just one small change. You get the reverse. Is it hard? Okay, Shilpa got it. Anybody else? Yeah, Nikita got it. That's good. Yeah, Pooja got it. So beginning to understand how, the loops have to be run both in the forward way and in the backward direction. 2, 3, 4. I think so. It should be one less. Let us see whether it works for us. Run it. N equal to 4. J equal to 0. What happened? I think so. I should build it first. Yeah. So I have to build the program. Yeah. So as you can see, first 4 stars, then 3, 2, and 1. So only change required was n minus I minus 1. So when I is 0, it would go up to 0 to n minus 1, that is 4 stars. Then I1, it will be 1 less. Okay. You could have done it this way also. You start with j equal to n minus 1 and j greater than equal to 0, j minus minus.
J minus.
Written like that also. Yeah. You got it? Yeah.
Yeah.
Yeah. Now, see, I can further challenge you. Can you tell me how to get this pattern now? So now that you have done both, I want this pattern, let us say. N equal to 4 only. it should further continue and generate a triangle like that. So what would you do? Okay, you did this first part up till here, n equal to 4, and this part is what? N equal to 3, no? With reverse, with inverted pattern. So soon after your first loop, you have to run the second loop with whatever logic that you wrote just now, that is reverse loop of j. Only thing is you have to reduce n by 1 and then start, so that you get a pyramid like structure like that. So I will keep it as an assignment in your thing later, but this is how we can use loops appropriately. All right. So a more practical example of nested loop is in sorting. So all of you are familiar with sorting techniques? Few of them, at least
No, sir.
bubble sort or selection sort.
No.
Some, yeah. Yes.
Of course, there are other sorts like quick sort and all that. So those are pretty difficult.
Quick sort, merge sort.
Yeah, merge sort and all. So at least we should be able to see how to do these things, bubble sort or selection sort. I will tell you how these things work, and then we shall see the use of nested for loop to get the sorting done. So if you look at bubble sort, you are given a list of numbers like this. Okay. Then what you should do is, in bubble sort, you just go on comparing the adjacent elements. So you compare 5 and 7. So of the two, which is smaller? 5. So if next number is smaller than the previous, you have to exchange. Otherwise, you don't have to do anything. As you can see now, next iteration you compare 7 and 4. Of course, other numbers will remain in their position. So now what will you do? You will swap 4 and 7. So I will swap here only. Okay. What will you do in the next iteration or in the next step? You compare the next two. So always you are comparing the next two until the end. So last but one will be compared with this at the end. Now 7 will shift to this position, 3 will come here. 7 will come here and 3 will shift here. After this, you will compare 7 and 9. Okay. So again, what will you do now? Will you swap or no?
Not.
No, because next number is bigger than the previous. So don't swap here.
Okay.
Then just move on with the next two, that is 9 and 2. Here again, last number is less than the last but one. So here you need to swap the 2. So when you do that, 2 will come here and 9 will go there. 2 and 9. Now as you can see, this is called one iteration. After one iteration, the largest in the list will be at the end of the list, right? So this is already sorted. We need to sort the remaining elements now. Okay. So after first iteration, you will be left with n minus 1 elements. Here there were n elements. After first iteration, you will be left with n minus 1 element. Again, you have to start the same way. Again, start from the first two. What will you do at this stage? Next is smaller than the previous, so you will swap 4 and 5 here. Next, you will compare these two. Again, next is smaller than the previous, we swap these two. You compare these two. You'll see that next number is bigger than the previous, so you don't swap. You proceed with the next two. Here again, next number is smaller than the previous, you swap these two. Now you see that 7 is sorted. This is the second iteration.
Okay.
So once you are done with this, still the list is not sorted. Again, I have to go to the beginning of the list. Beginning of the list, again proceed like that. So here again you have to swap 3 and 4, 4 and 5, no swapping. 5 and 2 you have to swap. So you see that 5 is sorted. You are left with only 3 elements to sort. Again you go to the beginning of the list. You compare these two, no swapping. There is swapping now. 2 and 4. Now again 4 is sorted. You are left with only 2 now. So here you check with this. Again, next number is less than the previous. You swap 2 and 3. So now you see that the whole list is sorted. Okay. Now it is established that we require n iterations for n elements. Okay. So number of iterations will be n, and in each iteration, as you can see, progressively the number of comparisons are reducing. Okay. If you are in the ith rotation, you will be doing n minus I minus 1 comparison, right? That is, in the first iteration, what you did, in the 0th iteration, you went up to n minus 1. I was 0. If you put I equal to 0, you will be having n minus 1, because you have to compare last but 1 and last, right? This is n minus 1th element and this is the nth element. But if you are assuming the array to be starting from 0, then this is n minus 1 and this will be n minus 2. Okay, so you have to go up to n minus 2, or you can appropriately put the condition there to get the comparison done properly. So here also you see, to count the number of iteration you require a loop for I equal to 0, I less than n, I plus plus. Then for j equal to 0, you always have to start from the beginning of the list, and j less than n minus I minus 1. So this is the condition. We shall see why it is n minus I minus 1 with an example, and then here j plus plus. So in the inner for loop, you check if, assuming that your array is A with certain set of values, we have seen how to initialize array here. So if A of j and its neighbor, you can put greater than here so that it is easy to put. It is greater than j of plus 1. So if the next element is smaller than the previous, what do? You exchange the two elements. Now how to exchange we shall see, or else do nothing and then go back to this for loop. Okay, and then when you come out, you go back to this outer for loop. So when you come out of these two for loops, you will be having the sorted list here. Okay, so at the beginning, if you are not gone through a program like this, you may find it difficult, but we shall see with an implementation and demonstration how this whole thing works, the sorting. So let me quickly demonstrate to you how to do the sorting. So let me keep this value of n. Anyway, we are going to statically initialize an array. So let us say int a square bracket equal to 7 comma 3 comma 2 comma 5 comma 1 comma 9 comma 8, let us say some random set of numbers. So how many elements are there? 1 2 3 4 5 6 7 elements are there. So n is equal to 7. Okay, so I start a for loop I equal to 0, I less than n, I plus plus. So this will count number of iterations. Okay, and within this inner for loop there is a within this outer for loop there is a inner for loop which is again starting from 0, j less than n minus I minus 1, j plus plus. And here you are going to compare if a of j greater than a of j plus 1. That is, current element is greater than the next element. In that case, you will exchange the two elements. So the way to exchange two elements, you can write a function to do that. Since we are not studied functions, let me do it right here. You have to take help of a temporary variable. So you have to declare one more variable t. So since you have to exchange the elements in the array itself, you have to first copy either of the two in a temporary variable. I'll copy j into t. A of j is free now. So in the a of j position, I copy a of j plus 1. And now a of j plus 1 is free. And then in a of j plus 1, I'll copy t. So these are the three statements which will exchange the elements at position j and j plus 1. Right? So since there are more than one statement, I'm putting a opening flower bracket and closing flower bracket. Alright. Now, if you observe carefully, this inner for loop has only one statement, if statement, starting from here and ending at the last flower bracket here. So no flower bracket is required here. You don't have to put a flower bracket here and here. If you want, you can put, for clarity, you can do so. Similarly, for this outer for loop, there is only one for loop as one single statement. So again, flower bracket is not required. If you wish, you can put one for loop, one flower bracket here as well, just for clarity, so that you know where the inner for loop is ending and outer for loop is ending. So here you can write a comment, inner for loop, and this is outer for loop. Yeah. Now after sorting, you have to print it. So for again one for loop, I equal to 0, I less than n, I plus plus, printf percentage d with the space comma a of I. Okay. So this is a program which will sort these elements. As you can see, the input is in a random order, and if you run the program, what happened? Expected an extra semicolon bracket has come here. Okay. So as you can see, 1, 2, 3, 4, 5, 7, 8, 9. So this is a sorted list.
I have a question.
Yeah.
So under if after if you have given that t equal to a of j, right?
1 minute. I'll get back to your question. Where is that?
For reversing condition to swap numbers, we have given condition.
Yeah.
Right?
Yeah.
So it is like if that condition is satisfying, then
Yeah. Only
this whole
then.
block.
Only then you are swapping. Otherwise, no.
Okay.
Correct.
Okay.
So would you like to try this out?
Yeah.
Just go ahead. So declare an array here. So nesting of loops is to be practiced through examples like these, so that you are comfortable using 2 loops, 3 loops, the way it is required. When it go to matrix multiplication, you require 3 loops. So that is one very good exercise to look at. So let me know how many we can get it. So you can write a comment here. Exchange the neighbors if present element is bigger than the next element.
It will move on to next, not do anything with it.
If it is equal, it will not do anything.
Same like if it is lesser, it will not do anything. It will move on to next.
Yeah.
Okay.
Okay. So you are now comfortable, right, with nesting?
Yes, sir.
All right, that's good. That's good. So in the exercise, I'll ask you to do selection sort, which is slightly different from this. In that, what we do is we don't compare adjacent element. We compare first element with the rest of the elements in the first iteration, then second element with the rest of the elements in the iteration, like that. So in the selection sort, let's see one example: 7, 3, 5, 2, 9, 8, 1, like that. So in this, what I do is, in the first step, I compare first two as before. All right. Now you see that 3 is less than 7, so I exchange like this. Okay. So in the next step, I don't compare 7 and 5. I compare again 3 and 5. So here I don't exchange because 3 is smaller than 5. I proceed further. So I compare with 2 now. Now 2 is smaller than 3. I exchange. So 2 will come here.
Okay.
And your 3 will go here. Then again I continue with the next number. I compare with 9, nothing happens. I compare with 8, nothing happens. So after one iteration, this is one iteration, you see that the smallest number is at the first position. So you don't have to, it will not take part in the next iteration. So you have to leave this aside. In the second iteration, you should start with the second number. You will compare with this onwards. So 7 is compared with 5. An exchange happens here. Next, 5 is compared with 3. Exchange will happen. Yeah. Now 3 is compared with 9 and 8. Nothing happens. So you are done with that iteration. Again, you will see that 3 is sorted in the list. Done. Now you compare again with 7 and 5, like that. So 5 will move here and 7 will move here. 5 and 9, 5 and 8, nothing happens. So 5 is sorted. Then
Okay, one more.
try with 7 and 9. Nothing happens. 7 and 8 also nothing happens. This is sorted. 9 and 8 are compared. So here the swapping happens.
Okay.
8 and 9, and you are done with the sorting.
All the elements.
Yeah. So in the selection sort, it is first with rest. Okay, in the first iteration. Second with rest of the element. In the last iteration, n minus 1 iteration, n minus 1 and the nth element has to be compared. Right? So you know how many comparisons will happen, what for loop will look like, and what j would look like. Any guesses here? How should I start the for loops? This will remain the same. What will happen to the inner for loop? J equal to
n minus 1.
yeah.
Compare with the
J is equal to I plus 1.
J equal to I plus 1 or j equal to I?
J equal to I plus 1, sir.
I plus 1, na?
Yes.
Yeah. J less than what?
N minus 1.
N minus 1 only. Okay. It will go till the end. But here while comparing, you have to compare A of I with A of J now.
J.
Not A of J and J plus 1. Because in the 0th iteration, A0 should be compared with A1, A2 like that. Correct? When I becomes 1, J will be I plus 1. So it will be A2, A3 like that. What to do here? You have to exchange and repeat this. You get the sorted list. So I'll keep it for, assignment. You can try that out. All right. Now use of while loop also can be explored, but we are not going to explore a nested while loop, but a simple while loop. What if I tell you you are given a number like this, and I want to reverse this number? I want to get 3785. How do I do it? Okay. Now, whenever a problem like this is given, you have to think how I can extract individual digits of this number. Okay. So because I have to reconstruct its number taking 3, then 7, then 8, and then 5. If I can get access to the individual digits of the number, then I know how to combine these things to get the answer. Because if I get 3, I multiply with 1000, I get 3000. If I get 7, I know 7 is at the 100 position, I multiply with 100. If I get 8, I get the 10th position, and then if I get 5, is a unit position. Now if I add them up, I get 3785. Only thing is, how do I get individual digits of the number? Does any operator comes to your mind when I do this? We have seen arithmetic operators like addition, subtraction, division, multiplication, mod, right? So if you observe, if I take n mod 10, then what will happen? 5873 mod 10, it will find out 5870 and gives you remainder as 3. Right? So remainder comes out to be like this. So I know how to get this remainder. Right? Now, next digit when I want to get 7, I have to eliminate this. I have to eliminate this. The way to eliminate is if I do n equal to n by 10, then the last digit will be eliminated, isn't it? Because n is an integer. When I divide 5873 by 10, you get 587.3. Since it is an integer, this will be dropped. So you get 587. Now with this 587, if I go back, again I do 587 mod 10, then I get 7 as the remainder. So I'm getting individual parts, but how do I reassemble this as the new number? So what I should be doing is I should take the reverse number as 0 initially, and I should write an expression reverse equal to reverse into 10 plus the remainder. What will this statement do? That is, as you can see, reverse is initially 0. 0 into 10 plus remainder, first 3 will come. In the reverse value, 3 will come initially. Next, you get 7. But when you get 7, you are multiplying 3 with 10. So you will get 30 plus 7. You get 37, right? Next, when you get 8, you are again multiplying this by 10. You get 370 and then 8. 378 you get. Then next time when you go back, you get 5. That time again you multiply this with 10, you get 3780 and add 5 to it, you get 3785. So if I can repeat this, how long should I repeat? When as long as n is greater than 0. So I put a while loop here. So if I say while n not equal to 0, do these 3 steps. And if I print the value of reverse, you get the answer. Of course, printf has to be correctly written. So logic building is what you should learn when you are learning programming. So many times we tend to think that programming means only syntax of C program, but we should also learn how to solve a problem, knowing very well what each operator or each statement of a program does. All right. So we'll see an implementation of this, and if you implement, you will also realize how easily I can reverse a number. So I'll remove this. So I will take a number n. N is equal to what number we had here? 5873. Same number I'll take. 5873. Yeah, this is a number given to you. As a first step, I require a couple of variables here. So int we require a remainder variable, and then we require the reverse number which is initially set to 0. Okay. So the first step in the while loop is remainder has to be extracted. So remainder equal to n mod 10. So this will give you the remainder. Then the reverse number is to be reconstructed using this formula. So this will successfully multiply the reverse number by 10 so that the digits are in the correct positions. And now before you go back, you have to truncate the number by 10 and repeat this until n is not equal to 0. N not equal to 0, do this. And then if I print reverse number, and then before that you can print the original number also here before you start the while loop. Original number %d /n comma n. Okay, so let me close this. If I build the program, as you can see, 5873 has become 3785. Okay, yeah. So this is one intelligent use of a while loop where you get a reverse of a number. Can you just try this out quickly?
Yes, sir.
Yeah. So let me see you are getting it. Just type the message if you got it. Nested loops is suppose in your school days, I guess in school days you have this multiplication table, right? 2 1 the 2, 2 2 the 4, 2 3 the 6, okay, 2 10 the 20, okay, and then we have 3 1 the 3 like this. So can I generate this table by writing a C program? Can anybody guess how many loops to use and what is the outer for loop for this and what is the inner for loop?
2 for loops.
2 for loops. Good. That's a good guess.
Outer for loop will be for numbers of 2, meaning 2 times 1 is 2, right? So
Okay.
first
Okay. So outer for loop will be starting from
2.
2. I can go up to you want up to 9 here.
Okay.
Okay. 9 ones are so 9 tens are. So you can
9.
say I less than equal to 9 and then I
9.
plus plus, right?
Yes.
So what will be the inner loop?
For j is equal to 1 to 10.
1 to 10. Good. Now you are beginning to understand how this thing is working. And while printing, how will you print?
For percentage d cross
Star
t.
percentage D equal to another percentage D, right?
Yes.
And here, what should come as a first this thing variable? I.
I
Second is J. Okay. And
J.
third is I star J.
I star j.
Okay. And should I print slash n here?
Yes.
Yes.
Percentage d slash n is equal to
Slash n, no?
Yes.
Okay. Would you like to try it out?
Okay.
Okay, just see.
Sir, one question.
Yeah.
So consider there are given statements like this, correct? So how do we come up with a think this will come in the inner loop and this should be a part of outer loop? I mean, two loops are there, right?
Yeah, yeah.
That so how do we come to a conclusion of
Okay,
that?
okay.
Yes.
I got you. See, we want a table of 2 ones are, 2 threes are like this. So, how many uh, outer values? Now, if you observe this table, this is going
Yeah,
from 2, 3 like this up to
correct.
9.
Nine.
So, this
Yeah.
you can think of as a outer for loop.
Okay.
And
Okay.
within this for loop, we have 1 to 10 here.
Another
10
condition.
here, right? So,
Okay.
that is
Okay.
inner for loop.
Okay.
So, let me see who can do this. And any changes are to be done, where they are to be done.
So far.
You may not get this table side by side. You may get 3 ones are 3 twos are below this. Just see, because little logic alteration has to happen to get the way I have shown here. But let's see how to get that also. But at least if you implement this, see what you are getting. Are you getting all the one below the other? If you get that is also fine, but you should get up to 9 ones are to 9 tens result.
Got it, sir, but I'm not able to paste everything in the chat.
Yeah. So they will be one below the other, right?
Yeah.
Yeah. So what you should do to get it, 3 2 ones are 2, 3 ones are 3 on the same line. So what changes you have to do? Just think of.
Okay.
2 ones are 2. Should it be that J loop should be outside and I should be inside? And this slash n should come after the one row is complete. If you're getting it, try this out. You want 2 ones are 2, then a tab here. Maybe you can put a tab, then 3 ones are 3, then tab like that till the last. And after you complete this row, you should slash n here so that it goes to the next line. Then say 2 ones are 2 like this. I think so that J loop should be outside here.
No, JLoop is giving an error, sir, outside. I mean, it is not displaying proper output.
Okay.
Uh,
J equal to 1. In that case, this I and J should be exchanged, or how is it? No. No, that is correct. 2 ones are 2. That is correct. 2 ones are 2. Then 3 ones are 3. So let me try this out. If any of you are getting me, let me know. It's you change. Int J for J equal to 1, J less than equal to 9, J plus plus for I is equal to 2, I less than equal to sorry, this J should go up to 10 and 9 I plus plus printf percentage thing into percentage d equal to percentage d slash t comma I comma j comma I star j, and when you come out of the inner for loop, I want one printf here or just 2 slash n I can give, and I should put a flower bracket here because I want both of these to be executed as part of this. Now let us see. Yeah, what happened? 2 3 are 6. 2 on the 2 is not appearing. Oh, I think so that space is too much.
Yeah.
I can remove this slash t and leave it like that.
So single slash t would be fine.
Yeah, 2 on the 2, 3 on the 3, like that. So 2 on the 2 up to 10. I gave 2 slash t here.
Previously you were 2 slash t, now it is just single
Single
slash t.
slash t should work. I think so I have to enlarge the screen. Yeah, now it's fine. So you can see 2 on the 2, 2 to the 4, up to 20, 9 on the 90. Just a little change here. J loop should start first and then I loop. All of you getting this?
Yes, sir.
Just give a try. Good. And it's little practice and similar kind of problems if you can come up with, that will be great. And the square ones can also be done 1 square, 1 and 1 square, 2 square, 3 square, like that. But that you can try out later. That is good. So you should work a variety of problems of this kind so that you are comfortable using any nesting of loops with proper ij values and get yourself comfortable using any of these loops. All right. Yeah. So one other small problem which I have in mind, just 2 minutes and we'll close for today. See, I want to build a calendar: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and then possibly you can start with Sunday. And given the month, the number of days in the month are given. You can say days, month, or whatever. Let us say it's January and they're given 31. So assuming that first one start on Sunday. So 1, 2, 3, 4, 5, 6, 7. And once you get 8, all right, you are starting a for loop for I equal to 1 to 30, right? Or 31. Once you get 8, I want to get to the next line here. Okay. So how do I check whether I've reached 8 or not? Any guesses? Is anybody trying to join?
Some length of array.
Yeah. So this 8 should appear on the next line, 8, 9, 10, like that. Whatever, and the last 31 should come there wherever it ends. So displaying a calendar using a for loop, you can try. That is, only trick is how to identify that you have reached end 8 or multiples of 8. That is, if I check if I is mod 8 equal to 0, right? Then you have reached this part, and then here you can give a printf with /n so that it goes to the next line before printing the other numbers. Okay, so little trick like that you can apply and get this table. So I'll leave this as an assignment and you can try this out. It is only one loop, just that within the loop you have to just check this. This Sunday, Monday you can print as one printf statement with /t as a heading, and then next row you should start with 1, 2, 3 up to 31. If days of month are given as 31. If it is 28 and you have to, if it is leap year February, you have to stop at 28 here, wherever it ends, like that. So only days possible are 30, 31, 28 or 29. So these are the only values that days of month will get. You have to read that through keyboard, and accordingly this calendar 1 month calendar can display. Okay. So what we saw today is the use of nested if, use of nested for loop, and the intelligent use of while loop to do a smart thing as reversing a number, and also display the multiplication table using two loops by appropriately choosing the j index and I index, and then putting a tab wherever required and putting a slash and after you're done with the first row. Okay, so also you can try printing a calendar of a month given the number of days in the month. So that you shall see how you can explore in the assignment part. Alright, so shall we stop here? Yeah, so those of your questions you can stay back, others can leave the session. Alright. Okay, Arpita, you had some.
Sir, selection sort if you can repeat.
Okay. So in selection sort, you have to compare first element with the rest of the element in the first iteration. Then second element with the rest of the elements in the second iteration, because you observed in my previous demonstration that the numbers are getting started from the beginning of the list, isn't it? After first iteration, the number smallest would be at the first position. So you don't have to consider that. You directly go the second with the rest of the element, which may be unsorted. And in the third iteration, third element with the rest of the elements like this. Now, if you see through an example, how it works is, this is your first element, right? Now in the first iteration, you compare first with the rest of the elements. So what will you do here? 3 smaller than 7, you don't do anything. You move on to see the next element in the list. So 3, 4, you don't do anything because the next element is bigger than the first element. Then you compare with 5, same thing happens, but when you compare this with 1, you see that first element is bigger than this element. So you exchange here. So what happens is this 1 comes here and 3 goes there. And you have to continue like this till the end, because you never know whether you got the smallest number at the first position. As a coincidence, 1 has come here. Probably if it is 8 is 0, then that 0 would have come to the first place. So when you compare first with the last element, nothing happens. So you are done with the first iteration. So after first iteration, if you see, one element is sorted and it is always at the beginning of the list. So you are done with this. Okay. So now you have to start with the second with the third, second with the fourth, like this.
Okay.
if you find a small element smaller than this, you have to exchange. So now 7 and 4, we will exchange 4 here and put 7 here. Isn't it? So we get 4 and 7 here. And again, in the next iteration, you take this and compare with 5 here.
Okay. So it's always first element with rest of the elements.
In the first iteration, first with the rest. Second iteration, second with the rest.
Okay.
That's the only difference. You got it?
Yes, sir.
Okay.
Yeah.
So if you repeat this n times, at the end of nth iteration, you will get all the elements sorted. Okay. So you take some numbers and work it out on a piece of paper. Then you see how the logic has to be built for the same, and implement the program, and you will see that this also works and sorts the elements.
Sure, sir. Yeah.
Okay.
Thank you.
So we'll close for today.
Yes, sir.
Okay. Thank you.
Thank you, sir.
Okay, thank you.